No, I don't have time for a fit check. We gotta crush this. We have to lock.
Okay.
And by we, I mean me. I mean me. Okay. Yesterday we left off here. Yeah, you'll see, Maddie, when you get to yesterday. You do get a shout out though. So. Yeah. Okay. So first of all, these question marks should be arrows. I don't know why it formatted like that. I know. So fix those arrows and change those question marks to arrows, like so. So we identified catalysts, intermediates, like so. And then we have the chemical reaction. W plus Y yields Z. Has the following sets of steps. Yes? W goes to R plus Y equals Q, and Q goes to Z. Slow, fast, fast. Flip the page. So you're going to have to kind of flip back and forth, but the rate is only going to depend on what? The rate is only going to depend on the concentration of what letter? So you're going to have to flip back. The rate is only going to depend on the concentration of what letter? From yesterday. W. Why? First of all, rates are only dependent on reactants. And second of all, it's only dependent on the rate determining step. Right? You guys okay with that? Do you guys remember talking about this yesterday? Yeah. Okay, good. Yeah. So the rate only depends on the concentration of W, since it's the only reactant, right? In the rate determining stepped. So the rate equation would be rate equals K times the concentration of W. And K is a what? A constant.
Different K or same K?
What do you mean?
As the one before.
Same K. Same K. Wow. Same K. So the order with respect to W is 1, right? Because it's just 1. Yes? Example 2. See, these arrows worked. I don't understand that. The chemical equation A plus B yields C plus D has the following sequence of steps. A yields Q, fast. Q plus B yields C plus D, slow, rate determining. Slow. So, what the? So, see, I saw so and slow. So the slow step contains what? Q and B. So the rate you would think would equal K, concentration of Q, times the concentration of B. But it's not.
Oh, so don't write it?
Because Q is what?
Oh, it's
Q's an intermediate. Agreed? Does Q show up here and go away there? So can I calculate the concentration of an intermediate? No, because it's there and gone. There's no way to calculate the concentration. So when this happens, see, I'm ahead of myself, which means this concentration is basically impossible to isolate. Let's say isolate. It's shorter than calculate. So we have to switch Q with something else from that equation. And because Q is in equilibrium, which means it's basically the same, with A, they can be switched. So the rate would actually be rate equals K times the concentration of A, B. That's the type of stuff that they like to throw in there. Not hard, all right? But an intermediate can never be part of a rate law. Cool? You go with that, Danny?
Yeah.
I would.
See if I see an example with actual numbers.
Okay, we will. We will. Example number 3, conceptually. Don't you love conceptualizing things? Yes. Rates can be determined pretty easily with a little brain thinking. I know, which is hard after all that food we just consumed. My sugar's still going up, so I'm feeling good. I got BrO3 plus 5Br plus 6H yields 3Br2 plus 3H2O liquid. So here's my equation. The results of 4 separate experiments are given below. And remember, it has to be experimentally in order to find a rate law. And by inspecting the initial rate, so here's my initial rate on this table. Data it's possible to determine the rate equation. Since the rate equation mechanism are I can't even say the words I wrote. Inexorably linked. Inexorably? Inexorably? Inexorably. I did, but I can't even pronounce what I was trying to say. Inexorably? Yeah. Linked. To deduce information about the mechanism. So here's my chart. From looking at this chart, we know the rate law. Or you will. Flip it. Flip the page. Same chart on the next page. Same chart because we didn't want to flip pages. So if I'm going to do this by inspection, other concentrations are going to have to be held what? Responsible. Not responsible, constant. Something has to stay the same so I can compare it to something else. Cool? So if I'm comparing the results of A and B, what happens to my BrO3? So if you would agree that my BrO3 was doubled, yes? Yes? BrO3 went 0.005 to 0.0010. So by doubling the concentration of BrO3 minus, BrO3 doubled. Did I just double? Doubling concentration of BrO3, doubled the rate. Because would you agree that the rate also doubled? This went up by 2, and that went up by 2? Yes? Therefore, the rate of BrO3 would be what order? If I double this, this went up also. This went up by a factor of 2, this went up by a factor of 2. What order would that be?
2.
Not 2. Because if I double this, that would go up by a factor of 4 if it was second order. It's first order. Does that make sense? If I double this and I double this, right, they're both going up by a factor of 1. If I would have doubled this and this would have went up by a factor of 4, it would have been second order. Got it? So, therefore, the rate of BrO3 is said to be first order. So you can tell by just looking at this. Just looking at this. Comparing the results from mixtures B and C. So in B and C, what's staying the same? These are staying the same. These are staying the same. So what am I looking at? I'm actually looking at Br. Agreed? Yes? Doubling my concentration of Br minus did what to my rate? I went from 0.025 to 0.05, and I went from 20 to 40. What did that do? Doubled the rate. So a double is a double. Therefore, the rate of Br is said to be what order? First order. You with me so far? Comparing the results of C and D. So this is constant. This is constant. What did my concentration of H do? Doubling H plus did what to my rate? Quadrupled my rate. Because you'd agree 40 times 4 is 160? Yes? So that quadrupled the rate. Quadrupled the rate. Therefore, the rate of H plus is said to be what order? Second order. I hope I hit record before we start this. We did. That'd be a lot to go back on. So, the rate equation for this law, for this would be rate equals K times the concentration of what? We're actually putting in things now. BrO3 minus, that's first order, so is it going to have an exponent? No. Times the concentration of Br minus times the concentration of H plus squared. Because H plus was second order. Agreed? Yes? Easy. Yeah? Just looking at it? I'm going to show you math-wise. What? And the numbers are usually going to be easy like this. It's going to be obvious what the numbers are when you're doing it like this. Then I would say, what's the K? So you'd have to solve for K. This is the hardest part. Solving for K is not bad. It's the units that are bad. So if I wanted to solve for K, I'm going to have to sub in any one trial into this equation. So let's just do the first trial. So I would say that I've got 10, right? Yes? Because that's my rate. So I would say 10. What are my units? Molar per what? Molar per time. Agreed? I've got 10 molar per time is equal to K, which is what I'm solving for. Yes? Times, sub in your concentration of BrO3, which is 0.05 molar, right? You guys see I'm just using the first trial? Okay. So times 0.005 molar times concentration of Br is 0.025 molar times concentration of H, 0.03 molar, but that has to be squared. Are we good so far? You're definitely going to need a calculator. Definitely need a calculator. So I have to solve for K. So K is going to be 10 divided by this, divided by this, divided by this squared. Someone tell me what they get when they do that. So I'm going to solve 10 divided by this, divided by this, divided by 0.03 squared. I'm going to need at least 2 people to confirm the answer. I'm just solving for K, right? So I have 10 divided by this, divided by this, divided by 0.03 squared. So I need a confirmation from at least 2 people what they get. Some people are just waiting for people to get it. That's fine. Swim meet tonight or tomorrow? Saturday. OCCs are Saturday? Nice. Dang, so the swim season's like coming to an end.
Conference happens like halfway through.
We still have like a
Oh.
9 months or
Okay. Got it. Anybody get an answer? What'd you get? So what is it?
It's just a bunch of-
8.9 times 10 to the what? 10 to the 7th. That's the easy part. Now I got to figure out the units. So what is my unit on the top going to be? Or am I going to have any unit on the top?
No.
Because I have moles, molar, divided by molar to the what power? I have molar divided by molar to the 4th. Agreed? M times M to the 2nd would be molar to the 4th. Yes? So it would technically be 8.9 times 10 to the 7th molar to the negative what? 3rd times time to the what? Negative 1st. Or you can write it like this. 8.9 times 10 to the 7th divided by Tm cubed, if you want to do it like that. Those are the same thing. Agreed? So like I said, the units are the hardest part on this. Not bad, just a little bit of algebra.
Will it always be that?
Will it always be this number? For every single trial, you would get the same thing.
But it's different for
Every different experiment, it would be different, yes. So a different experiment would have a different rate law, would have different numbers, would have to be a different constant, would be different units. Are we okay?
Yeah.
Okay. Cool? Here we go, number 1. For a reaction between x and y in the equation below, data has been collected in the table. Deduce the order of reaction with respect to each reactant, the overall order, the rate equation, a value for the rate constant, and the units of the rate constant. So, this can also be done mathematically. Some of you may not like just looking at it and figuring out if it's doubled or quadrupled. So I'm going to work the math out for you one time. Okay? So here we go. So, yeah, did I ever tell you that I lost my 6th grade spelling bee on mathematics? I spelled it M-A-T-H-A-M-A-T-I-C. Yeah. What?
Was it mathematics?
It was mathematic, but I spelled it with an A instead of an E. And you know what you got in 6th grade after you lost the latent spelling bee? You walked off stage, and Mr. Pierman, that was my 6th grade teacher, handed you a peanut.
A single one?
A single peanut in the shell. There was no peanut allergies back then. All right? I don't know.
That's the string.
He loved peanuts, and that's what you got. You walked off, and here's your peanut.
So did the winner get?
I don't want to say. Huh?
Did the winner get a lot of peanuts?
No, the winner got to like go on to states or whatever.
Oh, and you got a peanut?
Yeah.
That's why
Who
we're
you
doing
lose
like
to?
county and then it's like.
I don't want to say. Because here's the thing, I'm at an age where there are students in this school whose parents I went to school with.
First person to lose is whoever won.
Winning the spelling bees, like,
Catherine won, okay?
Who the frick is
Exactly. But then, I think I told some people this, then freshman year, I beat her for first chair trombone freshman band, and then she quit because of that. That's drama. Here's your peanut. I'm just saying vengeance. People in band understand that, okay? People not in band might not get that, but chairs are a big deal. Right? Yes, they used to be. All right? It was a big deal. Chairs in band. What? Yeah. Things were a lot more competitive back in my day. Because some people freshman year made it to symphonic band. But, all right, here we go. So here's the math. Here's the math. I'm going to start with rate 2 equals rate 2. So I'm starting with the second experiment. Starting with the second experiment. Rate 2 equals what? What is my rate for experiment 2? That equals? No, experiment 2. 4. Right? Which equals K times the concentration of 0.0100 to the power of X, because I don't know what that is, right? Times the concentration of 0.0250 to the Y. X and Y, any number. Divided by rate. What am I going to divide that by? Rate 1 or rate 3? It doesn't matter, but 1's going to give you easier math. Not 3. 1. You want to do rate 1, because rate 1 equals what? 1, which equals K times the concentration of my X is now 0.005 to the X times, the other one should stay the same, 0.025 to the Y. Do you see why I chose these two? K cancels out, these cancel out, right? Agreed? What's 4 divided by 1? So 4 equals, what's 0.01 divided by 0.005? What? No, 0.01 divided by 0.005 is 2
50.
to the what power? To the X power. So 2 to the X, what's X equal? Yes.
Wait, then
This
why
is-
would he do 1 then?
What?
Why equal 1 in this?
We don't know yet. All right, because now we have to do 2 experiments. Sorry. We have to do 2 experiments where Y changes and X stays the same. And why did I choose 2 and 1? Because this gives me whole numbers. Could I have done 1 divided by 2? Sure. Then you would have been dealing with half powers. Would you get the same answer? Yes. Do you want to deal with half powers? Probably not. Right? So choose the experiments that you want to do that. Once again, I am completely fine with you doing it like this, as long as you show some kind of work. But if you want to do it the mathy way, this is the mathy way. You get the same thing. So if I'm trying to figure out why, what am I going to put on top? Am I going to put experiment 1 or experiment 3 on top? 1. Yes. So rate 1 equals 1 equals K times the concentration of, I'm going to write my X's first again, so 0.005 to the X times 0.025 to the Y, divided by rate which one? because I got to keep x the same now to figure out y.
One,
Rate 3. Rate 3, which equals 1, which equals k times the concentration of x is still 0.005. 0.005 to the x times concentration, which would be 0.0125 to the y. So k cancels out, x cancels out. What's 1 divided by 1? 1 equals 0.025 divided by 0.0125 is 2 to the y. Yes? 2 to the what power gives you 1? 0. So y is 0 order. Because I figured out 2 to what power gives me 1? Right? 2 to what power gives you 1? Anything to the 0 power is 1. Yes? So let's write our rate law. So my rate law would be rate equals k times the concentration of x, what? What's x's order? X squared. So that would be the rate law. Do we need to do the solve for k again? You guys got it, right? Okay. So that's the mathy way to do it. Cool? Whichever way you like it is cool with me. Just show some kind of work. Just show some kind of work. I personally think this way is easier than this way. I don't know. Honestly, not sure. 2, for reaction between A and B in the equation below. Data is collected in the table. Deduce the orders of reaction with respect to each reaction, the overall order, the rate of equation, the value of the rate constant. Do it. Now it's you. So you need to do 3 things. Number 1, write the rate law. Number 2, give the overall order. So you have to add up your exponents. And number 3, solve for k with units. Solve for k with units. So I'll give you guys like 5 minutes to do it. So you can do it the mathy way, you can do it the conceptual way. You have to keep 2 things the same to compare. So either way is okay. Guys, did you see the wildfires out in California? That is wild out there. It looks like the apocalypse.
My sister has friends whose houses have like burned down.
I'm sure.
Crazy.
And it's so hot with the winds, nobody can go above in like helicopters and try to put them out. Like it's 100-mile-an-hour winds. Whew. It's nuts.
Have you seen, I don't know if there are any pictures from this time around, but a couple, maybe 2-3 years ago when this was happening again, Did you see the pictures from like nighttime in San Francisco, where it would be like 3 in the morning, but because there was so much smoke in the city and there was so much light from the fires, it would be just like glowing
Yeah.
red in the air.
I remember that.
Those were like some hellish looking pictures.
Oh, yeah, for sure.
Like terrible, but like
Yeah.
kind of cool pictures.
It's kind of how it was here when, when the wildfires, like, from Canada, like, it blew up.
All that smoke,
I
yeah.
was up on the lake, like, when it happens, and, like, some mornings you'd be able to, like, smell it.
Oh, it does like that.
I know. Did you see it?
I did.
Did you see it, Danny?
Yeah.
It actually is really, I could, like,
What
I
is it
could
telling you to do? Is it telling you to drink water?
I'm using behind drinking water.
drip some.
I will. Are you guys done?
Wait, and then when you set it back down, why does it light up again?
Because that means I took a drink. So it's like measuring the drink.
We did that this morning. That's bad.
Did you get it back hooked up to your phone yet or no?
I didn't. I forgot about it, but I'm glad that Danny got to see it. 2 equals. I'm going to do the Matthew way just so you guys can see it one more time. So 2 equals 2x. Did you guys get first order for both?
Yeah.
Good. So my rate equation would be rate equals K times the concentration of A times the concentration of B, right? And what is my overall order? What's 1 plus 1? Second order, yes. Second order. Did you solve for K yet?
Yeah, I'm just figuring out how to use it.
Okay. Solve for K. So pick any experiment, pick any row, sub it in. You guys done? What'd you get for your number?
0 times 3.
8,000. Right? So K equals 8,000. I have molar divided by molar squared. Right? So it's going to be m to the negative 1, and then my s's don't change. It could be 8,000 divided by m times s. Either one. Cool? Okay. Flip it. Using the rate equation determined in question number 1. So question number 1 was x squared, right? So let's write that down. So rate equals k concentration of x squared. Determine which of the following proposed mechanisms is valid. So I would have to say, is mechanism 1 valid? Or is mechanism 2 valid? So first thing to look at when I'm looking at a mechanism is what is the RDS, right? Yes? So here's my RDS on mechanism 1. Here's my RDS on mechanism 2. So number 1, I've got A as my reactant. Agreed? Is that X? Is AX? No. Over here, I have X plus B gives me Y. Yes? Okay. But here my equilibrium. Do I have an intermediate in this one? Oh, shoot. On this one, X is an intermediate, right? Yes? So let's write that down. So X is an intermediate, right? That's an intermediate. That's an intermediate. This is an intermediate. That's an intermediate. I also have Y, but I don't care about Y that much. So I have A is in equilibrium with X. So if I go here, if A is X, I need to have an X squared. Yes? Agreed? So do I have any way to make this X squared? Can I turn this X, can I turn this B into an X? No, I cannot. So my real one is going to have to be, if I'm going to add these all up, I would have X, B, comment on the role of X in both, those are intermediate. Determine which of the following proposed mechanisms is valid. I feel like we're missing information here.
If it's,
Well, the second-
isn't it number 1?
Yeah,
Shouldn't
number
the
one.
A contain the X in step 2?
Yes. Because here, this A, right, is an X, correct? So this A and X can basically flip. And then X plus X would give me X squared. So it's mechanism 1. It's mechanism 1. Guys, my brain is working really slow today. I'm sorry. I apologize. I apologize. Okay. Do you guys have a graphing calculator with you?
I mean, I have on the counter on the Chromebook.
On the Chromebook?
Yeah, there's a dozen of those graphic calculators.
Can you graph with it?
Yeah.
Okay. Do you guys all have a way to graph?
Yeah.
Do you have your book with you?
There's an online copy.
Can you pull up the online book or get with somebody that has a book? This is the last thing. So we're going to turn to page, well, let's talk about the integrated rate law first. The integrated rate law. When you hear the word integrated, what are you thinking?
Integer.
Integers, total integration. Thinking about math at all? Okay, let's just keep going. The integrated rate law relates concentration to reaction time.
I'm trying to remember, like,
The order of the rate law, 0, 1, or 2, is determined by what variation? By what variation of the concentration versus time on a graph creates a straight line. So we're going to have to graph these. So I'm going to have concentration of A, natural log of the concentration of A, or 1 over the concentration of A. So if a graph of the concentration of A versus time gives me a straight line, that is 0 order. And you got to just know that. Concentration of A versus T is 0 order. If I have a graph of the natural log of the concentration of A versus time, and that gives me a straight line, that's first order. And if I have a graph of 1 over the concentration of A versus time gives me a straight line, that is second order. So those are the 3 possibilities. So we're going to have to actually graph these. So first of all, let's talk about rate. You guys would agree that rate is a change? Yes? Yes, it's a change over time? Or I could say the change in the concentration of A over time. Rate is change over time. Yes? Would that also mean that the slope of the graph is going to be equal to the what? And what we signalize rate by? K. Rate is K. Open up your book to page 480. Open up your book to page 480. Graphing calculator of some sort you will need. Sorry, I should have told you. Or Desmos. Desmos should be able to do the same thing. My batteries are dead? No. We don't have to start throwing things. It's not that big of a deal.
I feel threatened.
All right, I'm going to get batteries. Did you guys find page 480? Online book? 480. 480 while I'm looking for AAAs. Do I even have AAAs? Come on, come on. Yes! It's a win. Big time. I think we're going to finish this. I believe. So, battery, cover. Wait a second. Oh, here we go. Okay, we're back. Guys, I've had this calculator since high school. It's my TI 83 Plus. Page 480. Page 408. Are you guys all seeing 480 somewhere, somehow?
I'm just guessing. There's no page.
There's no page numbers? Chapter 12. We're in 12.2. So we're looking for exercise 12.39. We're looking at this table. Looking at this table.
Yeah, if you just put that you want only page 480, that has a dimension page thing.
Okay. Can you guys see this table? Yes. Okay. We need to graph this data. So we need to graph this data. Okay, so I'm going to go to graph. No, I'm going to go to, not graph, second stat plot. Okay? So first of all, make sure plot 1 is on. So that's on. And then make sure you know what your X and Y list is. So X is going to be L1, Y is going to be L2. That's good. So I'm going to go to, that's good. That's on. Now I need to put in my data. So I'm going to go to stat. Edit. You guys with me?
We didn't know you meant this type of graphing.
Yeah.
Then.
Can you do this on Desmos?
No, it's just like each nighttime.
No? X and Y?
Yeah.
Yeah, that'll work.
I just
That'll work.
pasted it.
That'll work on Desmos.
Oh, I see. I see.
That works.
I just copy and paste it.
So, remember, my stat, we make sure we type this in right. I think L1, what was it? Second stat plot. L1 was my X. So I'm going to type in for L1, I'm going to type in 0, because that's my time. 50, 100, 200, 300.
Why is time?
Well, for me, L1 is my X.
Yeah. I thought time was, oh wait.
How do I get to that again?
Stat, if you're on a TI. And then I've got 400. So that's my L1. So that's good. So my L2 is going to be 0.1, 0.0.
I think you can go back to that.
Point 1, 0.0707, 0.05, 0.025, 0.0125, 0.00625. Does that data look good?
These are not interested.
Yes. That looks the same as what the book has, right? Do you guys have data inputted? Yes? So this is assuming that this is zero order, because I'm putting in concentration versus time. I've done nothing to my data. So the first time you ever graph this, you're always assuming it's zero order. You guys ready for me to show you how to get the graph?
Yes.
You're going to hit graph. It's probably going to look like nothing. And then you're going to hit zoom 9.
Oh, I see. It's like a dot.
Is that a straight line? No. That means this is not zero order. So I'm going to go back to my stat. Edit. Now, I need the natural log of all those numbers to see if it's first order, right? So I'm just going to go down here. I'm just going to go up here and hit second insert. Ooh, crap, that's not what I wanted to do. Delete. No, what did I do? How do I delete that?
You gotta name
I
it.
don't know. Name.
Names.
But I don't want name. Clear. Okay, good. For L2, I'm going to hit enter. Now I'm down here. Now I'm going to hit second insert natural log. And that'll take the natural log of the whole list. Hit enter. Natural log done of all of them.
This is zero.
Got it.
Okay? Can you do that in Desmos?
No.
No.
That's supposed to stay on delay.
It doesn't know.
Is there a way to insert natural log before your list?
Yeah.
This actually might be
Just
easier.
type in LM. Yeah, you just click the function button at the top on the title and then press it.
I actually believe Desmos is going to be available on AP test. So, for your technical.
Yeah.
You should have negative 2.303, negative 2.6.
LM.
Yeah, that'd be a good idea.
You guys got it? Yes? Did it work? Henry, you got it? Does anybody need help? Are you on Desmos, Henry?
No, I just.
You just hit on the calculator? Yes. So I went up here to L2, I hit enter, and then down here, I hit second
Oh, it's down here.
insert, and then I typed natural log. And then I hit enter, and that took the natural log of my whole list. Are we together?
Sure.
Yes? So I'm gonna hit graph again. I'm gonna hit zoom 9 again. Is that a straight line? Yeah. It is. I can even check with a piece of paper, okay? That's definitely a straight line. What was funny? If you wanted to check the R-squared, you could. Now, I need to know the slope of this line. So I need to go to stat, calc, 4, which is my linear regression, hit enter.
You have to,
Can you do that on Desmos?
I think you have to, on your calculator, change the.
I don't think that's.
What do you mean?
Because we're using the LN, we're not using,
I don't think that's.
But it'll still give it to you. This is with the ln.
doesn't it? Oh, it is?
Yeah.
It just knows that?
Mhm.
Wait, how do you get to that?
I went to stat, calc, linear regression, which is 4, enter. Can you get that on Desmos? No?
I got a stat error.
I can just.
A stat error?
Yeah, now.
You might need to fix your stat plot.
Yeah.
Oh, you can, there's like a little.
Oh, that's-
Are you good with Desmos, Reese?
Yeah.
How do you get linear regression of the line?
God, I have no idea.
I'm good at this. No, I don't know how to do that.
There's no linear regression thing, you can do that.
Oh.
There's math.
Oh. People that are using a calculator, did you get what I got?
On mine, I had to actually put it in the back seat of the ticket list.
See, I used this. It was the same list though. I didn't change. I just changed the list. Did you get it, Will?
Wherever-
That's
Yes.
what I got. I got.
Oh, because I put I put them in a different list.
Okay, I didn't put them in a different list.
Okay, that's-
Ella, did you get it?
I don't know how.
There's a way to get it on Desmos. I'm not super good at Desmos yet. I'll admit it. I've got room to grow. Okay. You got it? Same numbers as me?
Wait, which is linear regression?
You accidentally put-
Yes.
Linear regression. It should be on.
Yes, you got it, Haley?
I have the same number.
Negative .006, B, negative 2.3.
Wait.
Some people are getting it. I think this is easier on a calculator, but okay. I now have everything that I need. Here's why. I know that y equals mx plus b. Agreed? So y equals, they gave me my slope, correct? That's the a on my calculator. So y equals negative 0.00693. I think that's far enough. X plus the b is negative 2.30. I don't know. Let's round that last one. 3. We good? So that tells me a lot. So I now have, what is this? This is that's my K. Now, I have a piece of paper for you. This is going to change your life. Change your life. So, shoot. Cut this in half. This has all of your rate laws. Take one, pass it back to both rows. Take one, pass it back to these 2 rows. It's super helpful. Who did not get one yet? Here you go. Here you go. Guess why I'm giving this to you? This is on your equation sheet for the AP test. So this is not something that you have to memorize. Everybody get one? Who did not get one? So I know that this is what order. Yeah, you don't have to memorize this. Also, here's half-lives. It's like a front-back full page. It's a lot. Here's this. These are half-lives. You got extras?
I hate stats because I miss
You.
more than half.
Well, yeah, that's tough. Here's half-lives.
It's not hard. I don't get why.
Okay. I'm going to fly these last couple minutes. So I am looking at first order. Yes? I know it's first order. So I know the half-life. If I want to know the half-life of this, it would be 0.693 divided by K. Agreed from here? Yes? Because I'm first order? Yes? So this would be equal to 0.693 divided by what? Not negative, because on here, first order, slope is the negative. So it'd actually be divided by positive 0.00693. And that gives you 100 seconds. So the half-life of this equation is 100 seconds. Does it make sense why this was positive? Because my slope on a first order is negative K? Okay, so the last thing I could ask you, and this is pretty much in the chapter, how much of A is left after 250 seconds. How much of A is left after 250 seconds? So I'm going to use the integrated rate law for first order to figure this out. So I would write down natural log of the concentration of A is equal to negative KT plus natural log of A concentration naught. What is A naught? What? Initial. And what is my A naught? It's here, right? It's the initial concentration from the book. So, let's sub in what we know. So the natural log of A is equal to the negative K. So negative, put this in parentheses, 0.00693 times, I'm trying to figure out 250 seconds, and parentheses, plus natural log of,
If it's negative K, wouldn't that be? Or wait.
well, this is just the negative of K.
Yeah, they're.
Yeah, and K is negative already, or would it be switched because the slope?
Well, my slope, right, was already, my slope was negative, so it's putting it negative again, right? Plus natural log of 0.100 molar. Does that make sense where I got all of those numbers? So that means natural log of A, you solve this out, and that gives you negative 4.035. How am I going to figure out A? What am I going to have to do? How do I undo an ln? E to the negative 4.035. Therefore, A equals, that would give you 0.0177 molar. So, that's what we're going to do with this. It's just math. Other thing you have to know is a first order half-life. A first order half-life does not depend on concentration. You don't need it. The other thing I want you to know, a little star, units on first order K, this will really help you, are always, whatever the time is to the negative 1 power. So if your time is seconds, the units on K is seconds to the negative 1. If it's minutes to the negative 1. That is unit 7. That is unit 7. We did it.